Picture this, it's 11 p.m., a developer is tired, and they open a pull request with a small harmless change. Without CI configured, a reviewer glances at it, everything looks fine, and it merges. At 12:07 a.m., the on-call engineer's phone lights up, the checkout flow is returning $0 totals for every transaction. Now imagine that exact same scenario with a CI workflow in place. The push triggers GitHub Actions, just runs in 45 seconds, a test fails, and the PR shows a red X. The merge button is physically unavailable. The developer sees the failure, fixes the bug before going to sleep, and production never sees the broken code. That 45-second feedback loop is the entire value proposition of continuous integration. When you type npm install on your laptop, npm resolves the dependency tree fresh, potentially pulling in newer patch or minor versions than your colleague got last week. That's fine for local development, but in a CI pipeline it's a hidden time bomb. npm CI is different, it reads packagelock.json as an absolute source of truth, installs the exact versions recorded there, and fails loudly if the lock file doesn't match package.json. It also wipes node_modules before installing, giving you a completely clean slate on every run. The result is that every CI run, on every branch, on every day of the year, installs the exact same packages. The golden rule is simple: npm install on your laptop, npm CI in your pipeline. Before writing a single line of YAML, you need a Node.js project that actually has something to test. The minimal setup for CI is 3 files. First, package.json declares Jest as a dev dependency and defines a test script that simply runs the Jest command. That script name is the hook CI will call. Second, sum.js exports a function with real logic, simple enough to understand at a glance but real enough to actually break. Third, sum.test.js is the Jest test file. Jest discovers it automatically because of the .test.js naming convention, no configuration required. This 3-file foundation is all you need to build a complete, working CI pipeline. This is the complete workflow file. Save it as .github/workflows/ci.yml and push it, and GitHub activates it instantly. The on block is where you declare what triggers the workflow. Push to main catches direct commits, while pull_request to main ensures every PR gets tested before it can merge. Under jobs, you define a single job called test running on Ubuntu latest, a fresh Linux VM that GitHub provisions for you at no extra cost. The 4 steps flow in order: check out your code, set up node.js, install dependencies with npm CI, and run the test suite. Each step must succeed for the next to run, and if any step fails, the entire job fails and the PR is blocked. This is one of the most commonly misunderstood aspects of GitHub Actions for beginners. When your workflow starts, the runner is a completely empty virtual machine. It has Node.js, Bash, Git, and a bunch of standard tools, but it does not have your code. The actions/checkout action fixes that by running a git clone of your repository at the exact commit SHA that triggered the workflow, placing all your files in the runner's working directory. Without this step, every subsequent command would fail immediately with file not found errors. The v4 suffix pins you to the latest major version of this action, which handles authentication tokens, LFS files, and submodule cloning automatically, making it the one step you never skip. GitHub's Ubuntu runners come with Node.js pre-installed, but the version changes over time as GitHub updates the runner images. Relying on the default version is a silent reliability risk. Your workflow might work today and break 6 months from now when the runner ships a new node major. Actions/setup node solves this by installing the exact version you specify, with full support for node version ranges and the LTS aliases. The cache option is equally important. When set to npm, the action caches your npm package cache key on the contents of packagelock.json. If the log file hasn't changed since the last run, npm CI restores packages from that cache instead of downloading them from the npm registry, saving anywhere from 30 seconds to 2 minutes on every run. Every Node.js CI workflow at its core is these 2 commands in sequence, and the sequence is non-negotiable. npm CI runs first, wiping the node_modules directory and reinstalling every dependency from the log file. This is what puts the Jest binary on the runner's path. npm test runs second, invoking the test script from package.json, which calls Jest, which discovers your test files and runs them in parallel worker processes. Jest reports results to Stout and exits with code 0 if every test passed or code 1 if any test failed. GitHub Actions reads that exit code after every run command. 0 means the step is green and execution continues, non-zero means the step is red and the job fails immediately, stopping all subsequent steps and marking the entire workflow run as failed. When every test in your suite passes, Jest prints its success summary and exits with code 0. GitHub Actions marks each step with a green checkmark in the Actions tab, and the entire workflow run gets a green status indicator. On the pull request page, this translates into a green checkmark next to the required CI check, and if you've configured branch protection rules, the merge button becomes available. The whole flow from push to green check typically takes 30 to 60 seconds for a small project. This is the feedback loop that makes developers confident. Push your code, wait less than a minute, and know with certainty that your change didn't break anything in the test suite. A failing test is where CI earns its keep. When Jest finds even a single failing assertion, it prints the full diff showing exactly what value was expected versus what was actually received, with a caret pointing to the exact line in your test file, and exits with code 1. GitHub Action sees the non-zero exit code the moment the step completes and immediately marks that step, and the entire job, as failed. The workflow run gets a red X. On the pull request page, the CI check shows a red X with a details link that takes you directly to the raw logs where Jest printed its output. If you've configured branch protection rules, the merge button is completely disabled, no workarounds, no override for reviewers, no way to ship the broken code. A failing CI run is only as useful as your ability to prevent broken code from merging. GitHub's branch protection rules are what close that loop. In your repository settings, you navigate to branches, add a protection rule for main, and enable require status checks to pass before merging, selecting your CI workflow check by name. From that point on, every pull request to main must have a passing CI run before the merge button activates. Even the repository owner cannot bypass this without explicitly removing the protection rule, which creates an audit trail. You can also enable require branches to be up to date before merging to ensure that CI tests run against the latest state of main, not a potentially stale base. When CI fails and you click the details link on the PR check, you land in the raw log output of the workflow run. Jest's output is designed to be readable in exactly this context. Each test file gets a pass or fail header in green or red. Start here to identify which file contains the broken test. Below a fail header, Jest prints a bullet point for each failing test, followed by the full expect/receive diff showing exactly what value your code returned versus what the test expected, and a code snippet with a caret pointing to the specific assertion that failed. The final summary block gives you counts of test suites, individual tests, snapshots, and total execution time. Everything you need to diagnose and fix the bug is in these logs, no need to reproduce locally first. Test coverage measures what percentage of your code paths are exercised during a test run. By itself, coverage is just a number, but combined with a threshold enforced in CI, it becomes a quality gate. Adding the coverage flag to your Jest command activates Istanbul, which instruments your code and tracks every line, branch, function, and statement that gets executed. The coverage threshold configuration then fails Jest with exit code 1 if any metric drops below your specified minimum. This means a pull request that deletes tests, comments out assertions, or adds a large untested feature will automatically fail CI. The recommended approach is to set your thresholds in jest.config.js rather than as CLI flags, so they live in version control and are visible to the entire team. Every file created on a GitHub Actions runner disappears the moment the job finishes, including your Jest coverage report and any JUnit XML files. The actions/upload artifact action changes that by packaging specified files or directories and storing them on GitHub's artifact storage, where they're accessible from the workflow run page for up to 90 days. The critical pattern here is using if, always, on the upload step, which ensures the artifact is uploaded whether the tests passed or failed. This is especially valuable for debugging. When CI fails on a branch, you want to download the coverage report to see exactly which lines aren't covered, not just the exit code. Set retention days to a smaller number like 7 on high-volume repos to keep storage costs reasonable. You've now built a complete, production-ready Node.js CI workflow from the triggering events down to coverage thresholds and artifact uploads. Before moving on, let's lock in the foundational principle that makes everything else reliable. The question sounds simple, but the reasoning behind the correct answer is what separates engineers who understand CI from those who just copy YAML. Think about what deterministic really means in the context of a pipeline that might run hundreds of times a day across dozens of branches. What property of npm CI makes it the right choice, not just for correctness, but also for speed and for catching configuration drift before it reaches production? Select your answer and read the explanation carefully.